Thank you. Yeah, got that. Yeah, as Gemma mentioned, thank you for the introduction. My name is George Okeyo, Vice President, North America. I'll be moderating today's session. The theme of today's webinar is TMM125 screening on the surfer, and I believe there'll be data on the synchropatch as well. In essence, this webinar focuses on accessing intracellular ion channels and transporters in research and in drug screening. There are so many different types of membrane proteins in lysosomes, cation, anion transporters, proton pumps, ion channels, and many other integral and peripheral membrane proteins. That being said, defect in these membrane proteins leads to impaired lysosomal function and is associated with numerous diseases. TMM125 is one of those lysosomal ion channels and has emerged as a potential therapeutic target. In general, TMM125 is a constitutively active potassium and proton leak channel involved in maintaining lysosomal integrity by regulating pH, membrane potential, and autophagy. But that being said, there are many challenges encountered when targeting organelle channels or transporters, for reasons mostly because most have unknown functions, their solution environments not very well understood. Accessibility, of course, is a problem. The organelles tend to be small. Direct recordings are difficult, certainly because organelle membranes are intercellular. And so considering all these challenges, it's generally difficult to access them. But that being said, there are two platforms from Nanion Technologies that have been used for study of TMM125, automated patch clamp and solid supported membrane-based electrophysiology. But that being said, before I get into anything else, I'd just like to introduce the company for those in the audience who may not be familiar with Nanion Technologies. Nanion is a Munich-based biotech company founded more than 20 years ago at this point, and has grown to be one of the leaders in providing automated patch clamp systems. But over the years, we've grown to not only provide automated patch clamp systems, but also innovate in systems for artificial bilayer lipid membranes, recordings, systems that are used for cell analytics, such as those used for label-free real-time cellular readouts, like impedance systems, extracellular electrical recordings, contractile force measurements, which would be the flex site, as well as systems used in solid supported membrane-based electrophysiology. Now, considering that, clearly, we aspire to be that one-stop shop for membrane science. So if you have any project whatsoever related to membrane recordings, we likely have a solution for your applications. Therefore, please let us know how we can partner with you in accelerating your research using one of our technologies. But for now, I'd briefly like to touch on those systems that were used for generation of TMM125 data, which would be our automated patch clamp system, synchropatch 384, as well as the surfer technologies. We have pretty much 4 automated patch clamp systems, the PortaPatch family of instruments that record one cell at a time, but have add-ons for external perfusion, internal perfusion, their capabilities of temperature control, and so on. And then we have the patch liner that can perform 4 or 8 cells recorded at a single time, which gives about 600 data points per day, translating to anywhere between 75 and 300 compounds per day. The patch liner is pretty flexible and allows for use with add-ons such as temperature control and dynamic clamp. And then, of course, we have our high throughput synchropatch 384 that can record up to 20,000 data points per day, with other capabilities and features such as rapid solution exchange, making the SynchroPatch 384 suitable for working with fast sensitizing ion channels. We have temperature control, which includes heating and active cooling, internal perfusion capabilities, and current clamp, therefore working with the action potential measurements. And of course, high throughput concentration response curve generation. But that being said, the SynchroPatch is not only usable for screening of large compound libraries. Using the 32-well mode of operation, SynchroPatch can actually become like a lower throughput system that would be usable for smaller screens and for assay development. Therefore, allowing the system to only use a fraction of the chip and the pipetting head in multiples of 32. Talking about the surfer, there are terminologies that you'll hear about, or acronyms that you'll keep hearing about today. SSM stands for solid supported membrane. And the name surfer itself comes from surface electrogenic event reader. There are two of these systems, the surfer N1 and surfer 96 SE, that at this point are used in academic labs, pharmaceutical companies, CROs, and many different settings where similar type recordings are performed. I'd like to briefly just touch on the measurement principle, although Andre will go deeper into discussing more of this. The point I'd just like to make here is that the surfer, unlike automated patch clamp systems, does not do voltage clamping. Membrane transport is triggered by the application of a chemical gradient, which could be a substrate, an ionic gradient, or pH gradient. In general, the workflow involves registering basal conditions and then perfusion of the substrate, which, because of the capacitive coupling between the vesicles containing the transporter or protein of interest and the sensor, which has a solid supported membrane, we charge the membranes and an on signal can be generated, which is then turned off with the perfusion of a non-activating solution that gives the off signal, and the signal peak and integral are therefore used for the analysis. There are many features that I'd like to point out here, but of major importance would be that the recordings are stable for hours on the surfer N1. It's ideal for assay development and for academic research, but it's a single well recording system. Sensors look like what you have on the screen here. The surfer 96 SE, on the other hand, is higher throughput, recording parallel 96 from 96 wells, and it's very low sample consumption, up to you can use 0.1 micrograms of total proteins per well. One of the really cool things about the surfer 96 is that membranes can be stored at -80, so there's no need for continued cell culture throughout your screening campaign. And with that, I'd like to introduce our speakers, Andre Mazzoni, who will be talking about functional investigations of the TMM175 selective for protons and potassium ions. And he'll be followed by Adriana. But for now, Andre, please.